Now let's see the use of the Taylor's theorem. So we have to show that this left hand side is equal to this right hand side, and you can see that the 2 raised to the power x is common, and then you have the series for h going on till infinity. So let's see how that happens. Well, you have this, you'll replace h with 0 because the series you can see here is being applied on h, not x. So replace h with 0, and then you basically just have 2 raised to the power x. So f of x is equal to 2 raised to the power x. Now differentiate this with respect to x. So the first derivative is just 2 raised to the power x into the natural log of 2, because basically this is how, when you have a constant with a variable in the power, you just, when you derivate it, you write it down as it is, and then you basically take the natural log of the constant. So that's ln 2. Now f double prime of x is basically, you see this term, well, you just multiply it with another natural log of 2, so it becomes the natural log of 2 whole square. The 2 raised to the power x remains as it is, and similarly for the third derivative, the natural log of 2 to the power 3, the 2 raised to the power x remains as it is. Now apply the Taylor's theorem. Well, this is just f of x plus h into f prime of x plus h square over 2 factorial into f double prime of x plus h cube over 3 factorial into f triple prime of x, and so forth. For example, the fourth term would just be basically h to the power 4 over 4 factorial into f, the fourth derivative of f of x. So, and then so forth and so forth. You can see the pattern here, and so you see the left hand side is just the original function, and f of x was equal to 2 raised to the power x, h into f prime of x. F prime of x was 2 raised to the power x into the natural log of 2, and then you have this, you replace f double prime of x with what we found earlier, 2 raised to the power x into the natural log of 2 whole square, and so forth and so forth. You can see that f triple prime of x was equal to this, as you can see over here, and so forth and so forth. So for example, the fourth would be h raised to the power 4 over 4 factorial into 2 raised to the power x, and the natural log of 2 raised to the power 4. Well, this is how you proved it. And then you can take 2 raised to the power x common from each and every term, because, well, it can be taken common, and then you have basically the right hand side that was to be proven.